Welcome to the KontinuumLAB. I'm Jeppe and this is Kontrol Freak. I make a new MIDI controller in every video. I make it up as I go along using scraps that I have lying around, and then I jam for a bit and record another voice for the Kontrol Freak theme song, which is what's playing right now. This is my MIDI Kalimba, which I used to record that little track. It's made almost entirely out of recycled materials and components. This video shows how I made it. The rest of the song is at the end of the video. Let's go! Welcome back to the Kontrol Freak. I'm super happy to be starting this new series of Kontrol Freak videos because they're just so much fun to make. So today, to kick it off, I have something really interesting planned. I'm going to try to make a Kalimba MIDI controller. Possibly the first of its kind in the world, if I make it work. The Kalimba is also known as a thumb piano, which I think is kind of silly. I mean, you do play it with your thumbs, but the piano makes a sound when you strike the key, whereas the Kalimba makes a sound when you let the key go. As always, I've gathered some supplies here in this box, which are going to help make that possible. There's some electronics down here, recycled materials, simple supplies such as tape, glue, solder and so on. The box itself is also going to be part of the instrument, so let's get started. So, let's have a look at these goodies. The main characters in this drama are these 8 FSRs, force sensitive resistors, which are going to be the sensors for the individual keys. There's 8 of them because I happen to have 8 of them lying around. Every single one of these has already been used in some other project. These are going to be the main sensors for the keys on the Kalimba, each of them connected through a voltage divider circuit, and so each of them is going to need a 10K resistor. So that's what those are for. Then there's this bunch of scrap cable here, which is all recycled from other projects as well. I think this is going to be sufficient for today's project. And then, of course, as always, I have a bunch of female headers, which are going to allow me to connect to the Teensy breakout board. Speaking of which, let's go find that. And here it is inside my MIDI flute. I'm honestly a little bit sad to take this apart because it's very dear to me. It was a super interesting build. And it is a world's first, but such is the nature of the Kontrol Freak. Reuse and recycle wherever I can. So if you saw that video, you remember that I actually numbered all of these cables, so I will be able to bring back the breakout board and then plug it back in. But not today. Today I'm making something else. Goodbye, little flute. As I mentioned, I'm going to use this box here as the main structure of the Kalimba. It's just an old cardboard box that I received some package in at some point. It's seen better days, but I guess I'll maybe strengthen it with some gaffer's tape and then build on that. So the idea is that you hold it like this and then you play the keys with your thumbs like this. So there are going to be 8 keys across here in sort of like an arrow pattern, which is the classical Kalimba shape. In my case, I'm going to have 8 keys because I have 8 sensors, but it could be any other number of sensors, although I do feel like 8 sensors on this surface here is a pretty good fit. In order to make these keys, I found this old scrap wood here, which comes from a box of onions, and this is going to form both the structure that supports the keys as well as the keys themselves. So I'm imagining keys of this width here, more or less, that you then play with your thumb. So I can probably break this down the middle and make 2. That's it, I already have 2 keys. And then just make some more out of this wood here, and then use this one to build a structure that will support the keys. Now for the sensor part. So there's going to be 8 sensors, and so I want these 8 FSRs to be lying flat on this surface here, probably just taped down. And then I'm going to have a layer of this foam sticky tape, which is like roughly the same thickness as the wood here. Stuck down on top of that, and so now you can actuate this sensor by pressing down on the end of this, and it gives a satisfying thunk when you let it go. The exact height of this structure and the length of the keys and the position of everything is still to be determined, but this is the basic concept that I'm going with, so let's get started. No! No! Damn it. So the perfect material for this would probably be something like a popsicle stick, but I really want to just recycle materials for this, and I didn't have any old popsicle sticks lying around. So I found another couple of pieces of wood because I'm going to need just a little bit more for the main structure here. Okay, so I just decided how I'm going to do the structure for the keys. It's going to be kind of like a sandwich where the keys are held in place in between two pieces of wood. I'm going to glue everything together. Okay, so that's clamped down quite well. Now, while all this glue dries, I'm gonna go and grab some lunch. See you in a bit. So that's coming along nicely, but it's still not quite dry. Of course, there's quite a lot of glue on there. I think I'm gonna leave this here for now and then get to work on the electronics. So I have these 8 force sensitive resistors, and they're going to need 2 cables each. And so these two already have quite a lot of cable. That should be enough. So I need to solder 2 cables onto each of these. Excellent, so now each of the 4 sensitive resistors has 2 cables, and at the other end of these cables I will now need to connect the resistor and 3 female headers so that I will be able to easily plug it into my breakout board here. This is what the individual connectors look like. We have ground on one side, then the analog pin on the other side, and then a resistor connecting into 3 volts. And this is what it looks like when they're all connected to the breakout board. So if you don't have my fantastic breakout board, then this is what the connection looks like. Cool, so everything is looking really nice. All the connections are made. Of course, the breakout board is going to live inside the box. The sensors are then going to come up to the surface here through some slits in this material itself. And then finally I'll connect this key structure on top of it. But I can tell the glue is not completely dry yet, so I'm gonna just leave it here for a while longer and then come back and put everything together. Okay, so that is definitely completely dry now and feels pretty much just like one solid piece, which is what I was going for. Maybe I'll cut this off here. Yeah, I'm gonna cut that off right there. So when you look at this from the side, the keys are not suspended as high over the surface as they would normally be on a standard Kalimba. But that's okay. I want them to be suspended at a specific height, and that specific height is the thickness of this tape here. Or I could suspend them higher and then have 2 pieces of tape, one on top of the other. But what I'm trying to do here is to have an FSR underneath each key and then have some of this tape stuck to the key underneath it so that when you press down, the sensor is activated, and then when you let go, the software will take care of turning that into a note. So hopefully you can see how that's supposed to work. You see the foam pad underneath there. When you compress the key, then that will press on the force sensitive resistor, and then I will write some code that sends a note when you release it. So what I don't want is for any of these sensors or sticky foam to overlap in the sense that one key activates several sensors. So I'll have to be careful as I place them. Something like this should work quite well. The next one up here. Okay, next up I'm going to temporarily fix this to the box. Next up I'm going to cut the slits for the sensors to pass through. That's the first one. Make sure it's positioned right underneath the sticky foam here. That looks pretty good. Next up, stick it down with a piece of standard transparent sticky tape here. I'm not going to stick this down permanently for now, because I just want to quickly check if the sensors all work. So to do that, I just need to quickly plug everything into the breakout board, of course, and then draw a USB cable out from the box. Looks good. Let's get a USB cable. I'm just going to draw the cable out from the back where it's not in anybody's way. So let's see. Plug it into the Teensy and then stick it down with some tape so that it doesn't rattle around pulling on the microcontroller inside. Close down, fold over, and that's pretty much it. So the next thing I want to do is to plug it into the computer and write some code for it and see if I can make it work and make some noise. Let's go! Okay, so after a quick check of all the sensors, it turns out that 3 of them are not working. These 2 first ones on the side here and the last one over here. Right now I'm debating whether I want to just make a 5-key Kalimba or whether I want to try to dig up some more force sensitive resistors. Okay, I just decided I'm going to make a 6-key Kalimba. I'm going to find one more force sensitive resistor and install it right here, and I'm going to take off the 2 outermost keys. Like that. Okay, so I managed to dig this up from an old project. This is a pedal rack with 3 analog pedals. It snaps onto a maker beam, which is very cool. So you can adjust the positions of each pedal or even make a rack with several pedals more, which I did have at some point. Each of these contains a force sensitive resistor, and so I'm going to just disassemble this and see if I can recover those sensors. Sweet. Slightly dirty, but apparently a healthy force sensitive resistor. And there's already a resistor stuck onto the connector here, which is very nice and it's going to save me a little bit of time. Let me just quickly check if that even works, and otherwise I'll try one of the other 2 ones here. Sweet, that is fully functional. So now I just need to put it into place. So I'm going to just quickly remove the ones that don't work at all. Like this one here, which was broken down close to the solder. This one here, which I will investigate a little bit closer to try to find out what's actually wrong with it. So this one also has some heavy mechanical damage here around the solder spot on the sensor. I doubt whether this will ever work again. So just put those aside. I think I'm just going to tape these down here in the inside just to stabilize them a little bit so that I don't inadvertently break some more. Okay, so with that I think we have a fully functional but somewhat reduced kalimba here with just 6 keys, but I think 6 keys is fine. Just for this proof of concept here, we could maybe put like a pentatonic scale on there with the octave on top. It could even be like a blues scale or a number of other options. So I think that's going to be totally fine. Anyway, if any more of the sensors fail on me, then I'm pretty sure that I have 2 more force sensitive resistors inside these little pedals here. But for now, I'm just going to plug this in, put some code on it, and see if I can't make some noise. Let's do it. Nice. So, before I get into the actual kalimba code, there are just 2 things that I need to tell you first. One is that, as usual, I have cheated a little bit, and I've prepared all the code for the kalimba beforehand, because watching me code is slow and boring. So, no surprises there. The second thing is that the code for this instrument is by far the simplest code of any Kontrol Freak build so far. This is in part because I've just had a really crazy busy week. I was traveling now for 3 days, and so this has already taken far too long to complete. On the other hand, the instrument itself is also insanely simplistic and made mostly out of garbage. So I think the scruffy code and the scruffy instrument will make quite a nice pair, and everything should work out just fine in the end. So let's plug this in and see how it all works. So this is the first out of 3 files that I saved along the way during the coding process. As always, the first file is a very simple one. This array holds the 6 pins that the sensors are on. Then I have another array for the readings on those sensors. Here I set up the serial connection. And then in this for loop, I read the 6 sensors and I just print the results to serial. So let's try to upload that. So as you can see, we got an error message here in the Arduino IDE, but at the same time the Teensy loader seemed to confirm a successful upload. Normally this means that the upload actually worked just fine, so let's open the serial monitor and see. So everything seems to be working correctly here. We have 6 readings from the 6 sensors. So currently the reading is basically at the maximum. And as you can see, when I activate these keys here, the value goes towards 0. The resolution on these keys is more than sufficient for what I need. And funny enough, the second reading here has a much higher resolution than the rest of them. Which I can only guess must be because it has a different resistor value on the voltage divider circuit. So I'm not sure exactly how that happened. But anyway, that works just fine. Let's look at the next file. Here's the second file. And as you can see, I've added a couple of arrays here with these variables, which are the minimum and maximum reading of the keys. And I use these minimum and maximum readings to determine whether or not the key is active or not, and then I store that value in these arrays here. As usual in these MIDI controllers, I keep track of the last value that I read so that I can determine if there is any change to the new value that I'm reading now. Then in this for loop here, I read all of the keys and determine if they are active or not active. So then if the key is inactive, but on the last reading it was active, that means that I have been pressing the key down and now I let go of it. And so given that case, I serial print a note number to the serial monitor, and then I delay for 1.5 seconds so that I have time to read that off of the serial monitor. If that's not the case, then I simply print the keys as they come in, and so that's the same readout as we had in the last file. That's the whole thing. Let's upload that. That appears to have worked just fine. We have basically the same readout as before, but now if I play one of the keys, then the readout should stop and the serial monitor should show us the number of the key that I played. So let's try the first key, which is key number 0. And indeed, we have the display saying note 0, note 1, note 2, note 3. So notice that the note number does not come up when I press the key, but when I let go of it. Note 4, note 5. So the second file also works just great. Let's try to open up file number 3. So this is the last file, and as usual, this is where I incorporate everything having to do with the MIDI output itself. So as you can see, we have the same variables as before, but then added to that we have some MIDI note numbers here. These 6 notes correspond to the 6 keys on the instrument, and then in this case the notes represent a pentatonic scale. The main loop in this file is really simple. We have this first for loop here where we keep track of the last reading so that we can see if anything changed, and then the main for loop where we read the sensors and then keep track of the active or inactive state of each key, and then use that information to send a MIDI note on signal. So I wasn't kidding when I said that the Kalimba here is the simplest instrument of the Kontrol Freak series so far. There's no volume control, there's no aftertouch, there's nothing fancy here at all, just a simple MIDI note on signal activated like this. There's also no serial output, so as soon as we upload this file, then the serial monitor will stop outputting this stuff here. Let's try to do that. So the serial output is dead, we can close that down. And then I think it's time to open up the Yoshimi synthesizer and see if we can't use this thing to make some noise. Let's do it. And here we are. As always, I'm running the Yoshimi synthesizer through jack. And so all that's left to do is to connect the Teensy to Yoshimi through jack like this. And then we can close that down. For this first test of the Kalimba, I have selected a bass patch. This is one of the original patches that come with Yoshimi, although I have slightly customized it here within the instrument editor, specifically the sustain and delay values. So everything should be prepared now and the Kalimba should be fully functional. So moment of truth, let's try this first key. Yeah. So we're supposed to have a pentatonic scale here. Let's see if I got the numbers right. Yes, that's perfect. So that actually works. That's so cool. So the last thing that I want to test before I record some music is the polyphonic playing. There you go. That's really nice. So we could play 2 or even 3 notes at a time, or even all of them, which is perhaps not so musical, but you know, the instrument at least can handle it. So as you can see, the Kalimba is now fully functional and it's ready to be put to good use, doing what it was made for, and that is to record the bass line for a brand new Kontrol Freak theme song. Let's do it. Thanks for watching. If you enjoyed the Kontrol Freak, then like this video and subscribe to the KontinuumLAB channel where I post content like this every week. While you're there, check out the Open Horn MIDI system, my main project here in the lab. See you next time.